welcome to your favourite teacher. Today we're going to be looking at covalent bonding. A covalent molecule is formed between non-metal atoms. They form a bond by sharing electrons in their outer shells. They do not transfer electrons because they are not emptying the outer shells like metals in group 1 and group 7 do in ionic bonds. Don't get this confused with ionic bonding, where electrons are passed from one atom to another. So co means to share, and valent is a word for electrons. So funnily enough, when you put them together, you've guessed it, covalent means sharing electrons. Each shared pair of electrons creates a bond. These bonds are very strong due to the electrostatic attraction between the negative pair of electrons and the positive nucleus. This attraction is very strong and holds the atom together in a strong bond. Non-metal atoms can form multiple covalent bonds for the same atom. For example, carbon in group 4 has 4 electrons in its outer shell and therefore can form 4 covalent bonds by sharing 4 electrons to make its outer shell full. To get that optimum 8 electrons that they're all dreaming about in their outer shells. Nitrogen is in group 5 and has 5 electrons in its outer shell. So to get that magic number of 8, it needs 3 more. So it can share with 3 other non-metals. You always find 3 covalent bonds per nitrogen atom. Oxygen is in group 6 and has 6 electrons in its outer shell. It needs 2 to fill its outer shell, and so it shares 2 electrons to make 2 covalent bonds. Chlorine is in group 7 and has 7 electrons in its outer shell. It just needs 1 more, so it shares 1 electron with another non-metal to form 1 covalent bond. Are we noticing the pattern? Methane, or CH4, is one of the several covalent molecules you need to remember. It's made up of 1 carbon atom and 4 hydrogen atoms. Ammonia, NH3, is another of those examples. 1 nitrogen atom forms 3 bonds and hydrogen atoms form 1 bond each. Carbon has 4 electrons in its outer shell and needs 4 more. Oxygen has 6 and is missing 2, so they join together in a double bond, each oxygen atom sharing 2 electrons. This forms the well-known carbon dioxide, or CO2. Hydrogen shares 1 electron with chlorine to make hydrochloric acid, HCl. Oxygen needs 2 electrons and so it shares 1 electron each with 2 hydrogen atoms to form water, H2O. Covalent bonding doesn't just happen with different atoms. Some atoms can have a brilliant bond just between themselves. Diatomic molecules such as H2, Cl2, N2 and O2 are examples of this. Hydrogen and chlorine have 1 covalent bond each as they only share 1 pair of electrons between the 2 atoms, but oxygen forms a double bond as each oxygen atom shares 2 electrons to make 2 covalent bonds. Nitrogen forms a triple bond as each nitrogen atom shares 3 electrons, making 3 covalent bonds. We use dot and cross diagrams, 2D and 3D diagrams to show the bonds in simple covalent molecules. In a dot and cross diagram, each pair has 1 dot and 1 cross, highlighting that each has come from a different atom. The electrons in one atom will be represented using dots and the other using crosses. 2D diagrams show the bonds as straight, short lines between the element symbol. The 2D diagrams are useful for showing how many bonds are made and showing the shape of the molecule. 3D diagrams are very useful at showing the angles between the bonds and therefore highlighting that we actually live in a 3D world and not a 2D one. Giant covalent structures are formed by repeated covalent bonds. Diamonds aren't just a girl's best friend, they're also a giant covalent structure. Diamonds consist of repeated C to C covalent bonds. Each carbon atom forms 4 bonds with other carbon atoms, and each of those carbon atoms form 4 more bonds. This locks them all together so closely, making diamonds one of the toughest materials on Earth. Silicon dioxide is an example of a giant covalent structure. Each silicon atom forms 4 bonds and each oxygen atom also forms 2 bonds. Small covalent molecules can be linked together to form polymers. For example, in polyethene, the ethene molecules are linked together with covalent bonds to form long chains. There are videos available with much more detail on giant covalent structure later in this course, so don't worry if this has been an information overload. To summarise, covalent bonds are formed by atoms sharing electrons in their outer shells. These bonds are strong. Simple molecules have a few atoms and giant structures have numerous atoms held together by strong covalent bonds. Chains of molecules can form by linking together with covalent bonds. There are dot and cross diagrams, and they show the bonds in simple covalent molecules. I'm Miss Meeks with your favourite teacher, and we've been looking at covalent bonding.